Now on the screen, you can see a traditional on-prem architecture. In its simplest form, there is a user, for example a user in Munich, and the traffic goes through a firewall first, then reaches the application, and the application connects to the database. At first glance, this architecture looks familiar, but when it comes to day-to-day operations and scaling, it creates serious limitations and pain points. So let's go through the problems one by one. In this diagram, everything you see, the servers, firewall rules, network components, and the database has to be provisioned and managed manually. First, the entire process becomes highly exposed to human error. Second, when something goes wrong, troubleshooting and recovery take much longer. For example, on the database side, even a small configuration mistake, a wrong parameter, a single character, or missing space can lead to days of investigation just to understand why it is not working. So, manual deployments ultimately mean high operational effort and high cost of failure. If you build this on-prem, you must purchase and deploy all components yourself. And more importantly, if you need business continuity or geographic redundancy, you must replicate the same architecture in a second location. Let's use Germany as an example. You have data center in Munich, and for disaster recovery or business continuity, you want a second location in Frankfurt. With the on-prem approach, this means buying and operating same firewall model, the same compute capacity, the same storage, and same database architecture a second time. In other words, both cost and complexity increase exponentially. In the on-prem world, there are usually two typical scenarios for load balancing. Either you purchase external hardware like F5 or you license a virtual load balancer solution. But the real issue is not only the device or the license. The real problem is what happens when your infrastructure grows. The load balancer is not natively integrated into the platform in an automated way. So, when traffic increases and you bring up a new application server, that server should automatically be added to the load balancer. But in a traditional setup, you often still need to manually edit to the target group, configure health checks, update routing rules, and apply changes even during scaling. So, even scaling itself generates manual work. Auto-scaling is one of the hardest challenges in the traditional on-prem environments, and this has have two sides. First, the cost side. Let's say your application server needs 8 CPU and 32 GB RAM of peak times, but you don't need this capacity every hour of the day. During business hours, the load increases. At night, resources sit idle. But in an on-prem model, you still have to keep that capacity available, which creates a major inefficiency. Second, the performance and competitiveness side. Think about an unexpected peak traffic scenario. For example, you run a Google campaign and suddenly demand explodes. If your system is not prepared, new users experience slow page loads from the very first interaction. And instead of gaining customers, you start losing them immediately. And here's the critical point. You only realize the load when it happens and then you try to add capacity or provision new service. But that creates a delay. And in the digital world, that delay can directly turn into lost revenue. Most organizations do have monitoring CPU, RAM, disk usage, latency, everything is being observed. But in on-prem environments, monitoring alone is not enough because the actions are still manual. You may notice that CPU reaches 70 or 80%, but you still have to decide and execute the action manually. Add capacity, deploy new servers, rebalance traffic, and do it at the right time and the right way. And there is no guarantee this will always happen on time because human factors and operational workload always come into play. In most environments, the database is the heaviest operational workload because A database is not just software. It runs an operating system, whether Windows or Linux. There are patch cycles, security updates, backup policies, disaster recovery scenarios, and SLA expectations. And in on-prem deployments, all of this becomes your responsibility. And instead of focusing on product development, you might find yourself spending evenings or weekends on a database maintenance and upgrades. And the exact same challenges apply to Kubernetes clusters as well. Scaling databases is also painful. Moving from a single instance to a master standby design, implementing replication, testing it, performing failover drills, this can easily turn into projects that take weeks.